Good morning, everyone, or actually good afternoon, I'm sorry. Thank you for joining us today. I am Caitlin Myers, Training Coordinator at Sustainable Solutions Corporation. The focus of this webinar is enhancing building optimization with energy modeling. Our presenters will talk about what energy modeling is and how energy models are used to enhance building performance. Now let's get started because we have a lot of really good information to cover this hour. Real quickly, just wanted to let everyone know that this course is approved for PDH credit towards your professional certification. Also, just a quick reminder, this presentation is copyrighted. Now, for today, the purpose of this course is to help you gain an understanding of the benefits of energy modeling for performance optimization in both new building design and existing buildings. At the end of this presentation, you will be able to understand how energy modeling is a valuable tool to enhance both new construction and existing buildings. You will also be able to understand how it can be used to estimate the potential savings of energy efficiency improvements for new and existing buildings. And finally, you will understand how it can be used to optimize the building design for improved energy performance, reduced carbon emissions, and decreased operating costs. We have two great presenters today. The first presenter is Tad Radzinski, President of Sustainable Solutions Corporation and industry expert. With over 30 years of experience, he works with clients across a wide range of industries on corporate responsibility and sustainable development. Tad has certified close to 30 buildings to the LEED rating systems, including new construction, commercial interiors, core and shell, LEED for homes, and LEED for existing building standards. Our second presenter is Mike Campbell, Sustainability Specialist at Sustainable Solutions Corporation. As an engineer in training and a LEED accredited professional, he has extensive experience in green building design and practices, LEED building certification, energy modeling, and sustainable building operations and maintenance. As a reminder, today's webinar is being recorded and the link will be sent to everyone that registered. Tad and Mike will also be happy to answer your questions towards the end of the webinar, so please feel free to submit your questions through the side control panel at any time. And now, here's Tad.
Thank you, Caitlin. I appreciate the introduction, and I want to welcome everybody today to this webinar. I'm very excited to have you here. This is actually something that is a very valuable tool for us here at Sustainable Solutions as far as assessing energy performance within existing buildings and also optimizing performance in new buildings. And this energy modeling tool has been something we've used now for several years, and we've had great success with this. And today we're going to talk about not only the value of it and what it is, but we're also going to talk about a few case studies where we've had really good luck with using energy modeling to improve performance and to improve the design of new buildings. So before I get started, I just want to give a little background on some of the work we do here. And a primary focus of Sustainable Solutions has been what we call sustainable buildings and operations. When I founded the company back in 2001, this was a key focus area for us where we did a lot of work on integrating LEED into new construction, both residential and commercial. And since 2001, we've really expanded these services to include multiple things, including Energy Star certification, energy audits, LEED certification, National Green Building Standards certification, and all kinds of different things, including sustainability assessments. And really the ultimate goal of the work we do is to optimize performance, reduce impacts on the environment and society, and basically save our clients money. The other area that we do a lot of work in is corporate sustainability, and if you think about it, everybody on the phone here, whether you are a building manager, a building owner, or you're working as a sustainability person or a facility manager, you all have buildings to manage. Whether you're managing a large office building, a portfolio of buildings, or even in your own home. Think about where you live and the things you can do to minimize your impacts and save costs. And buildings are definitely a major component of corporate sustainability. If you think about the impacts that are associated with buildings, they definitely will affect your triple bottom line of your company, and corporate sustainability programs definitely need to take a hard look at buildings and how to optimize the performance of those. The other thing, since we're doing a training webinar today, training and education is a huge component of what we do. We actually have come out and trained companies on energy modeling. We've done energy models for them and then trained their people how to use that software. The software we use in-house is eQuest, and Mike will be talking about that shortly. But that's one aspect of training we do. We also do a myriad of other training in regard to buildings and operations, sustainability, sales, all kinds of other great things. So as I mentioned in the beginning here, buildings are a major component of all of our lives. The average person spends about 90% of their time in buildings if you add it up, from the sleeping and working and being at home and whatnot. And operations of these buildings has significant impacts. So number one, we have a huge stock of existing buildings out in the world right now. Many of them are performing very badly when it comes to energy performance, water efficiency, etc. And I think there is just tremendous opportunity out there for reducing impacts by assessing performance of buildings. And the first step of that is usually a sustainability assessment, where you're going to benchmark the building, you're going to understand how energy is used, you're going to learn about a lot of the different systems, and then using that energy modeling that we're going to talk about in more detail here today to really optimize performance and to analyze various energy conservation measures is very important for existing buildings. And for new buildings, when we're designing them, the ultimate goal is, with all the impact that we have on the planet, we know there's a lot of impact from using electricity and burning fossil fuels and different things. So designing the building to be as energy efficient as possible is really important. And that's where energy modeling comes in the beginning when we're thinking about what we can do on a new building as well. But you can see some of the numbers here. This is from the United States Green Building Council. Typical building operation, 71% of electricity consumption, creates about 65% of waste, 39% of CO2 emissions, and buildings use about 12% of total water in the United States. So when we think about it, the fact that there's so much energy consumed in these buildings, and if you really put your life cycle thinking hat on and you're familiar with how energy is produced, especially electricity, it actually is one of the most impactful things we do as far as manufacturing anything. I spent 12 years working for an electric utility, and I can tell you that making electricity definitely has a lot of impacts. If you go all the way back to, say, a coal-fired plant, you got to go all the way back where we're getting the coal out of the earth, transporting that, burning that coal, and then releasing all kinds of different things, not only air emissions, but there's a lot of particulates and solid waste and mercury that come out of making electricity with a coal-fired plant. There are other options as far as renewables that can minimize impact, solar panels and wind, and that's starting to really take off. And then there's nuclear, and nuclear doesn't really generate any CO2, but we're basically stuck with very highly radioactive waste from every nuclear plant in the country that we don't really know what to do with. So a lot of things to consider. There is tremendous impact. And if you look at EPA's toxic release inventory, generating electricity definitely is probably in the top 2 or 3 as far as impacts reported to releases to the environment. And we also have to factor in that we also burn fuels for heating water, running boilers, different things like that. So burning oil or natural gas or even coal or even biomass for that matter definitely has impacts as well. So the fact that 65% of a building's primary energy use is typically electricity, it's very imperative for all of you when you're doing any kind of energy analysis is to understand the grid mix in the region where you are and what those impacts are of how the electricity is made, what the typical feed-in is, and that kind of thing. And that's a whole other webinar we could do on carbon footprinting and understanding analysis. But I do expect that if you are a building professional, you should have some idea of where your electricity comes and the typical grid mix on how that electricity is produced. So we're talking about the word energy modeling, and really what energy modeling is using a software program to basically determine energy use of a building through various computer simulations. And you can see in this slide right here, it's an example of a building, and you can see this building is modeled, basically a floor plan of every space in the building. And the great thing is when we do that, we can actually get down to the detail of understanding, in this particular room here, how much energy is being used. We can input the information about the equipment and all kinds of different things there. We can also look at like the number of people in that room, number of computers, and factor all that into our energy model. I mentioned earlier we use eQuest as our software, and that does basically simulate hourly energy use of a building. And that software program basically extracts information based on weather files for different areas of the United States that we're doing our modeling in. So, for example, the weather here and climate here in the Philadelphia area is going to be a lot different than in Arizona or, southern Florida, or again, even Michigan, because of weather extremes and whatnot. The way energy is used in the building, it's very important to evaluate it against the current weather and climate data, and that helps to really understand how energy gets used. And the great thing about energy modeling is once you get the baseline, your building input into the model, and Mike's going to talk about this, but typically what we'll do is we'll build usually a model. If it's a new construction, we're going to build a baseline building to comply with ASHRAE 62 or ASHRAE 62 90.1. I'm sorry, and depending on what version of LEED we're going to be using, it could be version 2007, 2010, and basically that sets the parameters on how we build a model for an existing building. For new buildings, excuse me. For existing buildings, what we're going to do is take all the data on the electricity consumption, the fuels burned, and we're going to basically input the information on the building envelope, the systems, and the floor plans and whatnot, and then we can actually model very closely how the building's using energy once we understand like airflows for air handlers and things like that. So it's a little different on how you do this, because think about it, when we're working on a existing building, we have a lot of data. We're going to have energy consumption data, we're going to have fuel consumption data, we're going to have information on airflows and all the equipment that's in the building. When we're modeling a new building, we have to really think about, first of all, this thing's on paper, so we're really trying to just predict energy use based on the best data we can following ASHRAE 90.1 like I mentioned earlier. So the big question is, why do we even care about creating this model? Well, number one, if you're going for LEED certification, especially LEED NC, you are going to be required to do an energy model because you have to demonstrate minimum energy performance. And then for optimizing energy performance, an energy model is one option that you can do, again, modeling to ASHRAE 90.1 to verify that you're meeting, setting up a baseline building and then doing your proposed building design as your second model and then comparing those two. Another big thing that drives energy modeling are incentive programs. For example, New Jersey has a clean energy program called Pay for Performance, and Sustainable Solution is an approved partner for that, and we actually have about a dozen buildings that we're doing right now under new construction that are working towards earning Pay for Performance incentives. And the great thing about this is energy modeling is a requirement of this program for both new and existing buildings, and the energy model is the way you demonstrate the performance you're expecting in the building, and that based on that performance is how you get paid incentives, and it's on a per square foot basis. So that's just one example, but I know other states around the country have similar incentives. Other utilities have similar incentives. For a while, we actually had some tax incentives, Act 179D, which just expired in 2013, which allowed us to model energy performance, say for lighting systems, building envelope, and HVAC, and then earn basically tax write-offs based on that energy performance compared to ASHRAE 90.1 2001. There's also some regulations and building codes that may require this. It's a very valuable tool, like I said, for existing buildings when you're doing energy assessments. or if you're even doing renovations, or if you want to compare similar buildings. Now, there are other tools out there like Energy Star Portfolio Manager that will allow you to do benchmarking and whatnot. But Portfolio Manager, not to be confused with an energy model, allows you only to basically track energy performance and compare to other similar buildings. And it only gives you basically a score of, an Energy Star rating, plus you can get how many kBTUs per square foot you used, carbon footprint, water use, and things like that. Whereas energy model is going to allow us to get in there and really dig in, build all the systems in the model, and create a simulation that's going to allow us to really look at how energy is used in the buildings. So like I talked about a little bit earlier, new construction, you really want to start using an energy model early in the stages of design. Typically we're working in schematic design, if there's any architects or building engineers here, where we're working very closely with the architects and the whole design team to evaluate things like window-to-wall ratio and various other things to understand how the envelope's going to perform, how various HVAC systems can perform. And in a minute, Mike will talk about how he does these things called parametric runs, where we'll build a baseline model and then we change things and we kind of compare, what each energy conservation measure or energy design aspect is going to do to the performance of the building. I do want to qualify, though, that energy modeling is a science that is as good as we can do right now. I would not say it's a perfect predictor of actual energy performance on new construction. And you've probably read some articles and different things where a LEED building's energy performance isn't matching the model. Well, there's a lot of fine-tuning going on in the world, and I know there's some DOE initiatives to try to improve the modeling software and whatnot. But it does give you the ability to do a measured means of evaluating different options for buildings and predict energy performance. And that's where you can compare alternative scenarios. Now, on existing buildings, like I said, we're going to take all the existing data about the building and then try to match the utility bills based on the equipment in the building. And once you do that, you can very precisely get an understanding of how energy is being used in the building, especially if you don't have any meters. A lot of times buildings only have one utility meter. They don't have 2 meters or 3 meters, or different systems aren't metered. And it's really great when you can go in and build an energy model, because then you can input data about all the equipment in there and start to really understand how energy is being used by different systems, like lighting or HVAC or pumps or air compressors, different things like that. And then once you have that in there, for the existing building, even much better than new construction, is you actually have real performance data based on the existing building as it stands right now. So then you can say, okay, now it's time to change. We want to maybe go with variable frequency drives on our fans, on our air handlers, or we want to model, going to maybe instead of 32-watt lights, we want to model what it's going to have, what the effect will be of going to a 28 or 25-watt lamp, or going to LEDs or something like that. You can then really see what the change will be and get much closer real results, in my opinion, of what you can expect in the building, because you are modeling it to the exact system and the current energy consumption. So that's just some good background on what energy modeling is, how it's done, and what I'm going to do now is I'm going to turn it over to Mike, and he's actually going to go into a couple case studies and explain to you both a new construction and an existing building case study in detail, and talk about some of the, the aspects of that. So I would encourage all of you, if you are having any questions at this point, you probably want to start emailing or sending them in here through the chat or the question bar on your control panel, and we'll be glad to answer them after we're done here. All right, Mike, turn it over to you.
Thanks, Tad. So like Tad mentioned, I'm going to be going through 2 case studies. The first one here is for a new construction energy model that I did, and the other one will be for an existing building energy model that I did. And like Tad mentioned, there definitely are differences in the process of modeling a new construction building versus an existing building. Obviously, with new construction, you're just going by design documents and the specifications and the planned operations of the building. Whereas for an existing building, you might have a little bit more information available to fine-tune that model and kind of get it closer to match the actual utility bills. So it is an important note, when you're modeling a new construction, it's hard, it's hard to really know what the schedules are going to be or what the operating parameters are going to be for the building. So, if you're working on a LEED project, I wouldn't necessarily expect the actual energy usage in the building to match what you got out of your energy model. But an energy model for a new building is definitely still very valuable in comparing alternative scenarios and things like that. So I'll talk about that a little bit. So just getting into this first case study for the new construction project, a little bit of background on the project. It's a 13-story multifamily residential building in New Jersey. We were contracted to do the energy modeling for both LEED as well as New Jersey Pay for Performance program, which Tad talked a little bit about before. So both of these programs do require an energy model to verify energy performance of the building against ASHRAE 90.1 2007. So what we started was in the early design stages, we worked with the architects and the engineers, and we used the preliminary floor plans, and we created a very basic model in the beginning, and that was with the intent of nailing down a basis of design for the HVAC systems, because there were still some questions up in the air about whether they were going to go with a heat pump system or a fossil fuel heating. And they also wanted to understand the effect on window area on the energy model and how that would affect energy use in the building, as well as our documented energy savings for LEED and pay for performance. So 3 tables here. The first table you see shows the energy conservation measures that we analyzed for this building, and these were basically put in after the model was created as parametric runs, like Tad mentioned. So the parametric run feature in eQuest allows us to take the existing model and then just change a single component or a couple components without having to make a whole separate model and then just go in and change the roof system, for instance. So the parametric run feature is really nice for that, and it also allows us to stack multiple measures on top of each other. So you can say, you see the first one there is the roof insulation. So we can say, we want to look at just, if we add more roof insulation, what's that going to do? And then if we add more roof insulation and adjust the wall insulation. So you can kind of see how that works out. So I'll just go through kind of the just each of these energy conservation measures briefly. So like I said, the first 3 were in regards to the building envelope. So basically, we have the baseline for each one of these is ASHRAE 90.1 2007, since this was a model for LEED and pay for performance. So, and then the actual proposed in this case was we created the actual roof construction and the wall construction as well, and we input the glazing characteristics, the U-value, and the solar heat gain coefficient. The next ECM is low flow plumbing fixtures, where we were able to model the actual domestic hot water loads and compare, and we have a schedule in there for how basically how hot water is being used in the building and when it's being used. So that number you see there represents the maximum hot water demand in the building, and that's the savings there was based on using low flow fixtures and things like that, like faucets and low flow, actually Energy Star dishwasher and low flow shower heads too. So that's just an example of something else we can model. They had high efficiency lighting in this building, Energy Star appliances, which we were able to model directly in the residential units compared to conventional appliances. We also modeled a high efficiency boiler. This is a little more complicated than because we were looking at a boiler system and also comparing that to the heat pump system, like I mentioned before. And we were also looking at 2 different scenarios for window to wall ratio in this particular model. So there were quite a few things going on. And then we look at the heating and cooling efficiency as well as the efficiency of the domestic water heater. So that was just a basic rundown of the energy conservation measures for this new construction project. And then you can see there, Table 2 shows basically our analysis of the boiler system for heating versus the heat pump system for heating, and also showing the effect that the window-to-wall ratio had on the model. So those percentages that you see there show the savings over code. So that in the top left there, that 21.14% represents the system with boiler heating, boiler supplied heating, and a 54% window-to-wall ratio. And that same system, when we brought down the window-to-wall ratio to 48%, we saw more than a 1% increase in energy savings over code. So, like I said, we used this model early on in the design stages in order to show the architects the impacts that the window-to-wall ratio would have on on lead as well as pay for performance. So, based on this, we were actually able to convince them to reduce the window-to-wall ratio, so we didn't miss out on any incentives for the building, and we didn't want to jeopardize any lead points either. And then lastly, we did a basic analysis just to show what the utility bills might look like for the different scenarios. So those were all taken into account early in the design, and we kind of kept the model, kept updating the model throughout the design stages just to, to make sure that we were still on track to get all our incentives and lead points. So, just for new construction in general, it's really good to start modeling early on because, as we all know, it's easiest to make changes and early on in the design versus waiting until the building is getting ready to be built and then starting to try and incorporate these design decisions. So I'll just go a little bit into the case study now for existing building, which we did. This was a 3-story lab building, which uses 100% outside air to supply all the spaces in the building. So there's no air being recirculated at all in this building. So ventilation is obviously a huge factor here. We were hired because they had a renovation that was set to occur. So the client wanted to understand basically how that renovation was going to affect energy usage in the building. So our general process was we started out and we did a building walkthrough. We took, an inventory of what kind of equipment was installed in these lab spaces and the office spaces. We took a whole lighting inventory. We reviewed design documents. We did a review of the building automation system and looked at some readouts from the BAS as well, just to gather as much information as possible. And then we created an energy model based off the floor plans and, like I said, the design documents, and tried to use actual data from the building automation system as much as possible, because when we know how the building is actually operating, that makes it that makes the model a lot more accurate than just designing it to the ideal situation. So we started out with that with the pre-renovation model, and then we collected the design documents the early design documents for the renovation that was set to occur, and basically used the parametric run feature to incorporate those changes into our pre-renovation model, which then created our post-renovation model. So that allowed us then to see the big changes here were in airflows to some of the spaces, as well as the airflow devices were adjusted so they could actually go down to lower airflows than they could previously go down to. So really the big goal here is to minimize outside air, since knowing that this is a 100% outside air building. So this slide just shows kind of some of the changes that were made to the model in order to account for the renovation that was going to occur. So the main changes, like I mentioned, were zone level design airflows. Since a lot of these labs were being renovated, they had different airflows. And like I said before, the minimum airflows were also adjusted, as well as a lot of the equipment that was in the labs. A lot of it was being removed and replaced with new equipment, so we had to account for the changes in equipment loads within the spaces. So we can see here we were able to come out with these results. We found out that we're expecting that they'll save about 5% electric based off of the changes to the equipment and airflows. So most of that is, you can see in the table below, we have a 5% savings for ventilation fans from the pre-renovation compared to the post-renovation model, and a 20% savings in lab equipment, and that was because of some of the equipment that was removed. We also came up with an 8% savings for chilled water usage. This building is supplied by campus chilled water loop and steam loop as well. So that's how heating and cooling are provided to the building. And there was over a 9% savings in steam usage, and that was, again, that was mostly due to the decrease in ventilation requirements for the labs. So some of the challenges of that we found when modeling this building really was accounting for the equipment loads, because you know, especially in a building with a lot of rooms and a lot of equipment, it's hard to account for everything and know exactly when the schedules, you know, when certain equipment is operating, and what equipment was installed at the time, you know, for certain months out of the year and things like that. So it took a lot of effort to really nail down the equipment in the building as well as the schedules. And then on top of that, part of this project here was to also look at some additional energy conservation measures that could be incorporated into the design while this renovation is occurring. So here's one thing we looked at, was supplier temperature reset. So as the building is currently operated, the air handlers supply 55-degree air to the VAV boxes, which then, you know, reheat the air as necessary to meet the temperature set points. So we found that by implementing a supplier temperature reset, which is now actually required by code for a lot of systems in some climate zones, we found that there'd be over a 20% savings in chilled water usage. And, you know, keep in mind these savings are, you know, this is 100% outside our building, so the cooling and heating requirements are very high for this building. But pretty significant savings there for chilled water and both steam, because we're reducing the amount of steam used for reheat due to that chilled water, or that supplier temperature reset schedule. Another energy conservation measure that we looked at was converting from 32-watt lamps to all 28-watt lamps, and this basically resulted in 11% reduction in interior lighting power, because it was almost primarily lit with T8 lamps. So you can see there we had a 1% savings in electric usage, but we took a little bit of a hit in steam usage because, you know, now that extra lighting isn't heating the space, so there's a little bit extra steam that's required to be used for heating the spaces. But overall, there would be a cost savings associated with that, because, you know, electric for this building is much more expensive than steam. And then one other energy conservation measure that we wanted to look at was an increased efficiency for the fan system. So this could be, we modeled a 5% increase in efficiency for the total supply fan system. So this could be either a more efficient motor or a more efficient fan, and this actually resulted in pretty good electric savings, because with a more efficient fan, you're not using as much electric to power that and supply the same airflow. But it also resulted in some chilled water savings, because within the model, it actually takes into account in this particular building, the fans and the motors were located in the airstream, so they were adding heat to the air as it's flowing through the air handling units. So with a more efficient fan, we actually end up saving some chilled water, because because we're reducing that heat addition to the airstream. So those are just some examples of some energy conservation measures that we can look at in a model, and it's really nice because we're not just, like I said, when we're looking at the fan efficiency, we're not just looking at the actual energy used in the fan, we're looking at it from a whole building perspective. So it's obviously going to have an effect on chilled water and steam usage as well, since that, like I said, that heat from the fan is being added to the supply airstream. So just to quickly summarize, for new construction projects, energy modeling might seem like, just like an extra expense for a lead project, or for if you're applying for an incentive. But if you do it early and often, you can really get some real benefits out of it over, not just showing compliance with ASHRAE 90.1, but you can actually use the model to incorporate design changes that can save money over time. And doing it early, you can make easy decisions that might not cost anything, like changing the orientation of the building to to better utilize the sun. So there's a lot of things that can be done when you start modeling early. And like Tad mentioned before, energy modeling is a good tool for comparing design alternatives, but especially for new construction projects, it's not always good for predicting energy usage, because things like schedules and actual operating characteristics can change from what they're expected to be. For existing buildings, modeling real data versus design conditions is always beneficial. Anytime there's real data available from the building automation system or from any temperature readings, if you log temperature readings on your thermostats or something like that, it's good to know the actual operating conditions of the building versus just the design conditions. It's for an existing building, it's good to add. Energy models are good for analyzing impacts of multiple energy conservation measures at once, because if you're changing your lighting and your HVAC, they're going to have an effect on each other. So you want to model those on top of each other versus just looking at them individually and then coming up with some sort of energy savings based on that. And like we saw with with that supply fan efficiency example, it allows us to better understand the overall impacts of any changes in the building. So not just looking at it from kind of one-dimensionally, it looks at the entire building. So just to revisit the learning objectives, you should now be able to understand how energy modeling is a valuable tool to enhance new construction and existing buildings. You should be able to understand how energy modeling can be used to estimate potential savings of energy efficiency improvements in new and existing buildings. And you should be able to understand how it can be used to optimize building design for improved energy performance, reduce carbon emissions, and decreased operating costs.
Great. I want to thank you, Mike, for that. That was a great presentation, and now we're going to have some time for questions. But before we get into them, I just wanted to add a couple key points here. Mike did mention that often when you have an energy audit done for a building, some engineer or some consultant's going to come in and they're going to do an audit, and they're going to basically do their best to understand how energy is being used in various spaces, and then try to come up with some energy conservation measures. And the problem with doing a typical energy audit is you're not totally understanding the effect on all systems of the entire building when you make those suggestions. So, for example, let's say that you came in and you're saying, okay, we're going to just change light bulbs or go to more efficient lighting. Then as you saw, because you're doing that, you're reducing the heat load in the space, which means you're going to basically have to provide a little more heating energy depending on what climate zone you're in. So those kind of things can have an effect. Same thing with, say, adding insulation to a roof. It's going to reduce your cooling load, or even going to a white roof, reflective roof. Depending on the climate zone, you could get some benefits from a cooling perspective, but you may not get the benefits that you would think in the heating season when a white roof is going to reflect that energy and basically not help to keep the building warmer in the winter. So that's the real value here. And we do energy audits, and oftentimes it at least gives us an idea of where the opportunities are. But I can tell you that our best energy analyses have been done where we've done existing building energy modeling in combination with our standard sustainability assessment. We actually did a manufacturing plant like this a few years ago, and that was really valuable to be able to model various systems in the plant and to really understand what the value was for de-stratification in the high bay spaces, for going with more efficient equipment, for using waste heat recovery off of air compressors, and all kinds of other things. So just keep that in mind. There are different ways to handle existing buildings, but this energy modeling is definitely valuable. And every time we do anything related to energy in a building, we're going to assess what incentives are available. We mentioned pay for performance. There's often Energy Star. There's usually utility rebates, and try to combine that to help offset the cost, even tax credits like I mentioned earlier. So with that, I'm going to jump into the questions here. We have about quite a few questions that came in. And the first question was, if no separate meters are operating in an existing building, how is baseline data collected for individual rooms or systems within the building? I'll take that one. And as Mike mentioned earlier with the existing building example that he did, we basically had to go through and inventory what was being used in the spaces and what the operating parameters were. For example, let's say that there's different equipment and it runs half a day or 12 hours a day on 5 days a week, then those are the kind of things you want to understand. Is not only how much energy the device consumes, but how it's being operated. Same thing with HVAC schedules and everything else. So there is definitely some work if you don't have individual meters on various systems to get out there and get that data and basically pull it together. Mike, is there anything you wanted to add on that? Or?
No, I think you pretty much covered it.
Okay. And the next one is a really good one. Is there a way to estimate degradation of efficiency over time due to wear or lack of maintenance? And Mike, I'm going to let you take this one because I think we just did a parametric run to simulate something like this.
Yeah, we did. And so I guess the answer would be there is a way. I mean, you can model pretty much anything you want. I mean, even if you can't do it directly, there's going to be some workaround that you can figure out. So we actually did this on an existing building model where we tried to look at the effect of dirty air filters on the energy usage in the building. So for that case, we came up with after doing some research, I came up with an estimate for what the change in total static pressure of the system would be for dirty filters compared to clean filters, and basically just made that change as a parametric run in the model. So there's no, in eQuest, there's no way that I know of to directly, to directly account for older equipment, but if you have some sort of a, do some research, come up with some assumptions on what the change, if there's any sort of change in efficiency, maybe you could model a 10% loss in efficiency or something to a certain system. You can always model things indirectly like that to come up with an estimate.
Yeah, and preventative maintenance is really an important aspect of any building operation. If you see, we assess air handlers, we assess various equipment, and you can have leaking valves that are losing steam or losing chilled water that are definitely going to have an effect. You can have situations like Mike mentioned where the air filters are really dirty and you're starting to need a lot more fan energy to maintain static pressure and whatnot. So evaluating that is an important aspect, and that was just one example of how we've been able to try to demonstrate what the effect was of not doing good maintenance, or even if efficiency of equipment wears down, motor efficiency drops or something like that over time. So that's something to keep in mind. The next question is eQuest a good tool for modeling complex geometry? And I'll let you take that one, Mike.
Well, I guess it depends on how complex the geometry is, but I haven't come across a building that I wasn't able to model to a reasonably accurate extent. If you have really complex curves or something like that, or curved glass, that might be something that's a little more difficult to model. But for the most part, anything that I've seen has been, I've been able to model to a pretty close resemblance of the actual geometry.
All right, so we have another question here. It says, we have already started renovations of our building. Is it too late to start an energy model? I would say that, if we've been pulled into projects before where renovations have started, and the value of doing that is, even though the renovations have started, you still have the ability to get that baseline model built and to then understand maybe some additional items that you haven't thought of as part of the renovation that can be done. Or maybe, the renovation is not too far along and there's still an opportunity to maybe go with some different equipment or better lighting or something like that. But also one valuable thing about this is you can also model, say, various scenarios in regard to operating schedules and different things like that. So, even though our renovation started, it is totally doable. We actually did a industrial building here in Pennsylvania a few years ago where the building was probably a third to almost half built, and then they decided they want to go for LEED. So we actually had to come in and do the energy modeling at that point. Luckily, the envelope was really good on the building. We didn't have a lot to change there, but it did allow us to really fine-tune things on the interior of the building with lighting, and this was a very intense process operation where there was a lot of energy and a lot of melting of different materials and whatnot, and we had to model all that as well. But it really helped us to do some serious analysis on waste heat recovery in that building, and I think because of that modeling, we were able to really optimize energy recovery and use of energy in the building. So we have another one. This one says, Mike mentions a challenge of new construction being the uncertainty of building usage after construction, not using a building to its intended use. Is there any energy auditing of building occupant behavior to understand where behavior could change to save energy, like unplugging lamps, turning off monitors, etc.? That's actually a very good question, and what we typically do, any energy modeling, we're basically expecting a certain level of performance and use by different occupants. But as all of you know, if you have children or you have spouses or significant others that never turn things off, that can definitely have a major effect on energy performance. So ideally what is best to do there is to try to get people involved in education early on when the building's first constructed. We always usually seek those tenant education or occupant education programs where we teach people about how they use energy can have an effect on the building. And then we try to take the control out of their hands as much as possible. Anything we can do to integrate into the building automation system to reduce the ability of them to turn things or control things is really what we like to do. So Mike, do you think there's any way to model occupant comfort? I guess you could assume, certain scenarios where things are left on longer than predicted, or, different things like that.
Yeah, I mean, it's obviously hard to predict, exactly what, if you're looking at a lighting schedule or, a schedule that you're inputting for equipment on when it's on, it's obviously hard to predict that, to 100% accuracy. But as far as energy auditing of occupant behavior, I mean, you can do things like data logging in spaces to look at when the lights are on, or things like that, or you can install temporary equipment to monitor, when computers are on and off and things like that, just to get a sample, and then maybe try and adjust behavior from there. But I would say this is, the occupant behavior part is definitely where it becomes tricky to model that, because you never know if there's people leaving lights on at night when they're not expected to be on.
Yeah, that's why if you can take the control away from the people, that's the best. I know that LEED promotes controllability of systems and whatnot, but you can still have that, but also have the ability to make sure things are turned off when they're supposed to. I remember many times doing energy audits on buildings where people said, "Oh yeah, the cleaning people turn off the lights every night," and the staff when they leave are turning off the lights. So you put in the data loggers, and you often find out that it's there's many times where lights are left on all weekend, all night, all kinds of different computers running, different things like that. So. Next question that came in is, what data do you need to develop an energy model? What are the various things? And I know we covered that a little bit, but is there anything you'd like to add to this, Mike, as far as additional data that's helpful? I know maybe talk a little bit about some of the BAS data that's helped you.
Yeah. So like I mentioned before, for a new construction project, obviously the only real information we have to go by are the design documents and specifications. So, but if think about an existing building, it's always best to have real data over design data. So whenever we can pull airflow information, actual airflows from the BAS, or if there's actual schedules that are input into the building automation system, that's always valuable information. So I would say whenever we can get real data over over design data, that's always going to be beneficial for the model, and making sure it's as accurate as possible.
All right, we have another question here. It says, should an operations assessment be done at the same time as an energy model is being developed for an existing building? And yeah, that's something that we definitely really recommend. Typically when we're doing an energy model for an existing building, we're definitely assessing energy performance in that building and benchmarking that and whatnot, but we also really like to take a hard look at how water is being used in the building, waste generation, like we talked about occupant behavior, different things like that. So when we can combine our typical sustainability or operations assessment with an energy model, it gives you the ultimate benefit as far as saving money and reducing impacts from building operations. And that way we can cover water and all kinds of other great stuff. So another question we had here that just came in is, have you ever used Energy Plus or for energy modeling? What is your opinion on this program? Well, like I can say, we typically use eQuest here. We have used Design Builder, and which I think has got Energy Plus behind it in the past. It's a very difficult software. However, it does give you some ability to do some things that eQuest is not capable of. For example, I mentioned that industrial building, and that was one where we did use the Design Builder software with Energy Plus behind it, and that was because we were modeling very complex processes that we couldn't really build in eQuest, and that's why we chose to do that. And I can tell you it was a huge learning curve for us, and from the perspective of efficiency in modeling, took a lot of time. But we are finding, in my opinion, Mike, you might want to just shed some light on what you think about eQuest, but for typical lead projects, pay for performance, standard buildings, I think it works pretty well.
Yeah, I mean, eQuest has definitely been good, and I haven't personally used Energy Plus, but I can say, I mean, a lot of it comes down to the modeler and not necessarily the program, because, I mean, if you're trying to model an Energy Plus and you don't have any experience modeling, or if you don't have a background in in building systems, you're not going to get a good model out of that. So it's I think it's not so much the program, but the user's experience with the program and knowledge of the buildings that are being modeled in the systems. But yeah, I mean, eQuest has been really good for us, and it's really flexible, and there's a lot of support out there for it, since it's such a widely used program.
There was another question that came in related to software, and the question was, is there any sustainability reporting software that includes energy modeling built into it? And I've never seen anything like that. Usually these softwares are very specialized on what you can do, and even the sustainability reporting softwares out there, there's several versions out there, and none of them are perfect. They do help you. I think it really depends on the size of the buildings and your operations that you're managing, but most, like when we work with a really big company, for example, we work with a big hotel chain, and they have, I think they have over 100,000 buildings in their portfolio around the world, and they built their own custom software for both sustainability reporting, but they also do have some elements in there that allow them to do basic benchmarking of buildings and a little bit around energy conservation measures, but not anything like you would get from eQuest or anything like that. So I haven't seen that out there. So it looks like we're coming down to the end of the questions, and I know there's a few minutes to go here. If there's any additional questions, we'll give you a minute to get that in, and if not, we're going to wrap it up, because I know everybody's got a lot on their plate and a lot to do. But overall, I think today was some great questions and good presentation here. And if I get no further questions in the next 20 seconds here, I'm going to turn it back to Caitlin, and she's going to wrap things up for us.
All right, thank you all for attending today's webinar, Enhanced Building Optimization with Energy Modeling. I will be sending out a recording of today's presentation and the presentation slides to everyone who registered and attended. But please feel free to contact us with any further questions if you didn't get a chance to ask your questions. And let us know if you would like this presentation to be conducted for your organization. Also, please sign up for Sustainable Solutions' next webinars, formulating the framework, designing your corporate responsibility program, and then we also have another one coming up, strengthening internal support for sustainability initiatives, both who are being presented by Tad Radzinski. And also, because our May Corporate Responsibility Revolution Strategy to Success seminar was so successful, we have been receiving requests to host the seminar again, and the next one is on January 28th in Philadelphia. This is a hands-on, action-oriented workshop that will help attendees create and implement a corporate responsibility plan that supports a successful business strategy. For more information, you can go to the website listed, or you can contact us directly. And just a reminder that there is limited seating, and early registration and pricing is only until December 1st. Thank you all, and have a great day.